Good morning. Is this, yeah, this thing is on. Welcome to my talk. XSS is dead. We just don't get it. It's actually not really a talk. It's just like me ranting for 1 hour, if that's okay. I think that's quite ideal for the early hours in the morning. I have the tendency to talk too quickly. If that happens, just like wave. I'm going to slow down if that's okay. Already. Shit. So, a quick word about myself. My name is Mario. I have been to the Confidence for many times, many years in the past, and then I did like a break for 5 years, and now I'm back here, and this thing is huge. This is awesome. So, I'm from Berlin. I lead a company that's called Cure53, as mentioned. We do pen tests, and I wrote some books and wrote some papers, and my core research topic is cross-site scripting. And I'm here because of the fact that I'm slowly getting bored by this topic, because I think that we're actually at the point of being able to solve it, but somehow we just don't want to. So this kind of corresponds with the titles, like cross-site scripting is dead, like there is nothing new to it, we just don't get it. And I want to kind of have a look at why we don't get it, what the problem is, and maybe find like a different problem during this particular journey. So, let's first see who is here, like what kind of people are here. Who here is a pen tester? Raise your hand, please. That's like a couple of people, that's good. Who here is a developer, security developer, or like a defender of web applications? That's not that many people, but that's also good. Who here is like a manager, like an ISO, a CISO, or something like this? One person, one, excellent. That's a tough one, all right. And who here is a bug bounty hunter? Who hunts for bug bounties? Also not that many. Usually I get more hands for this. Anyway, thank you very much. Let's get started and quickly talk about the structure of this particular talk. The first act is going to be the onboarding. We're going to learn why we're actually here, what we're going to be talking about, and then we're going to talk about a small historic overview, how we got here, because I think that's fundamentally important to understand. And then last but not least, or almost last but not least, we're going to talk about the problem statement, because we will learn that something is a problem and we need to fix it. And in the final act, I'm going to propose solutions. Most of them are garbage, but at least they're proposals, and we can maybe use them to kind of think about a little bit and eventually find something together. So, let's talk about the first act, the onboarding. Why are we actually here? Well, the topic we're talking about is cross-site scripting, but we don't want to kind of uncover new techniques because most of them have been uncovered. So let's go very much back in past and talk about what cross-site scripting actually is. So this is like a classic cross-site scripting situation, right? We have a URL, and there is like the get parameter, and then we put something in. Who here thinks that this is cross-site scripting, or that the result is cross-site scripting? No one. That's good, because it's not, because that's just a script injection. We just take something, we put it in the URL, and it reflects. Cross-site scripting as such is pretty much an attack where one side scripts the other across origins. This is not cross-site scripting. There is no multiple origins. We just call it like this, but it's pretty much wrong. Anyway, I mean, if you put Facebook Connect into your website or Google Analytics, that's actually cross-site scripting, but it's legitimate, benign cross-site scripting. You want that because they script your page across origin boundaries, and that's XSS, like in the classic meaning of the word. Anyway, that's a script injection, but we can call it cross-site scripting because why not? Because it goes so well off the tongue, and the name is just so nice, and we can kind of give it like this cool sound of XSS, and that works. There's a couple of different kinds of cross-site scripting. Like there's the easiest kind, the stuff that you put in via URL, via get parameter, or via post field of whatever you send over to the server, and that's usually called reflected cross-site scripting. Then there's persistent cross-site scripting, that is something from the database or any other storage system that then reflects on your site, so you can't find it in the parameters. Then there's DOM-based cross-site scripting that comes from only browser-based client-side properties. And last but not least, there's mutation XSS, something that the browser takes and forms into something that is bad, whereas the server thinks, hey, everything is fine here, this is valid markup. I think most of these categories are highly debatable. It's questionable whether they make sense, but this is pretty much what we go with in pen test reports and how we kind of line it out and how we kind of put it into shelves and basically say this is this particular kind of thing. So we know all this. This is not new. To be able to kind of understand how this all came together and how we arrived at this point and how we can actually get to the true problem statement of this particular talk, I would say let's go back in time. And let's go back a couple of years, more than 20 years, and let's go to that year where cross-site scripting was actually invented or found or first documented. And let's adjust our timeline, and let's say this is the year 0 after cross-site scripting. The year 0 after cross-site scripting is about 20 years ago, and we want to see how it all came together and what people did back then to realize what it is, to fight it, and to tackle it, because that's actually quite funny. The year 0 after cross-site scripting is the year 1999 of our current calendar. And it was the three kings called House, Scheme, and Port who came and visited baby Brennan Eich, who was born in an iframe. What he got was a blink mark. Now, this, of course, is directly not accurate. But in this particular year, Microsoft coined the term cross-site scripting. They called it like this. And they had a discussion in a blog post and basically said, like, so there's this thing, and you can like put stuff from somewhere into some other's website, and then it executes like HTML or JavaScript. How should we call it? What kind of name should we give to it? They came up with a couple of proposals back then. The first one was unauthorized site scripting. I actually like that quite a lot because it's kind of true in its meaning, but it really sucks to talk, like, to spell it out, to pronounce it. It's just not really fun, it's like too long. Then you have unofficial site scripting, which is a bit better, goes better off the tongue. Then you have URL parameter script, insertion, UPSI, nope. Then you have cross-site scripting, which eventually won the trophy. Then you have synthesized scripting, not sure who came up with that. And last but not least, fraudulent scripting. So all of them are sort of correct, but this one actually got the trophy, and the whole attack technique was called cross-site scripting and not OOPSI. Soon after, the first advisory from CERT was issued describing this particular attack, because back then people knew SQL injection, remote code execution, and all these things targeting servers, but this one was new back then, 1999. And they postulated that a website may inadvertently include malicious HTML text or a script in a dynamically generated page based on unvalidated input from untrustworthy sources, and so on and so on. And when input is not validated, to pretend malicious HTML from being presented to the user. And I think this is one of the most compact, most accurate descriptions of cross-site scripting. This is what's actually going on. Like, back then in the year 1999, they had it figured out already. So they had figured out the problem that they were just like millimeters away from the solution. But still, we're in 2018, and we still don't have a solution. Everybody has XSS, so that's a bit strange. Anyway, back then, the whole topic of web security was so small and so tiny that it was possible for experts in completely different fields, like, for example, human genome research, to, on the side, write like a book about web security, because web security, that's like just such tiny of a topic. And Lincoln Steen, in fact, a human genome researcher at the Cold Spring Harbor Laboratory, he wrote this particular book about web security in his spare time, and he also got it quite right. He said cross-site scripting allows a bad guy to trick an innocent guy into running code the bad guy wrote. Oop, that's quite accurate. Like, he completely gets what is going on here. He writes something, and the client kind of gets it across to the victim, and then it executes. That's more accurate than most descriptions than we read nowadays. But well, people started thinking about how to fix it. I like this one specifically. I like to read php.net, especially the docs, because there's hilarious comments in there. But this one kind of really, this one jumped the shark. It was from Jake McMahon at hotmail.com. And he was talking about how you can use HTML entities and HTML special chars to actually fix cross-site scripting. He said, this function is particularly useful against XSS. XSS makes use of holes in code, whether it be in JavaScript or PHP. XSS often, if not always, uses HTML entities to do its evil deeds. That's, of course, complete bullshit, but still, he says it. So this function is in cooperation with your script. Cooperation with your scripts, particularly search or submitting scripts, is a very useful tool in combating hackers. Right, that was about 13 years ago that people had this particular attitude. It's completely wrong content-wise. It has nothing to do with HTML entities. And still, that was the level of discussion that they had back then. I thought this would be like a very good example. So back then, we had a small set of tools that we could actually use as defenders to protect our websites against cross-site scripting. Escaping. Escape your stuff before processing it on the server to protect your database or whatever is going on there. And encode your stuff before echoing it to the user, because then you can't have HTML injections and you can't have cross-site scripting, right? It's a simple fix for a simple bug, for a very simple and very trivial attack, and pretty much we can say case closed, and that's it, right? But unfortunately not. It continues. In the year 2002, which should pretty much be like the year 3 after XSS, with the release of Internet Explorer 6, Service Pack 2, the first targeted mitigation against cross-site scripting was published and was introduced in this ancient browser that no one uses anymore, hopefully, and there was HTTP-only cookies. Now, thanks to HTTP-only cookies, it's not possible anymore for the attacker to steal cookies when they have a cross-site scripting situation. And back then, people were like, I don't know, is that really like so much of a contribution? Because let's be honest, if you really want to exploit a cross-site scripting attack, then you don't really give jack about cookies. It's like, come on, there are so many more sexy things you can do, but cookies? Who cares about cookies? So basically, lots of money and lots of resources were going into inventing something that didn't have any effect, where the attacker would say like, okay, so this door is closed, but there's like 1,000 other open doors, so let's take one of these. So what gives? Well, XSS was not quite yet defeated. I think HTTP-only cookies are still particularly useless. And I still think they don't make too much sense, but still we recommend them in penetration test reports. So I think the only scenario where HTTP-only cookies actually make sense is where you have the possibility of being able to find a cross-site scripting on a subdomain where you can't have plausible phishing or markup injections or don't have the possibility to steal CSRF tokens, and you have good cookie security, and you want to prevent that the subdomain XSS can interact with your main domain, and I think that's like the only thing where this really makes sense. Yesterday I learned something new, because yesterday I learned that there is like a new use case for HTTP-only cookies. So since yesterday or a couple of days ago, they make more sense than they did for the last 20 years. Or 17 actually, and it turns out that HTTP-only cookies can be used to mitigate attacks like Spectre, because by using HTTP-only cookies, you make sure that they don't even hit the renderer in Chrome or in V8, and that makes sure that you can't execute these kinds of attacks, and this is like a new layer that kind of makes HTTP-only cookies be useful again. But this just happened a couple of days ago, so, well, XSS is still there, it's still not defeated. To be able to kind of go further and cover all the complex cases that websites have and that developers create, we need to kind of find a way to determine who can execute scripts and who can't. So we have this escaping and the encoding, that's all fine, but we don't have trust yet. And again, Microsoft Internet Explorer in very early versions was the first browser to invent and introduce something that allowed us to add trust. So we could, for example, say, well, there is one site and that is ours. We trust this. This can execute JavaScript. But we want to embed another site with an iframe, and we don't trust this site because who knows what that stuff is. So we want to distrust it. And there was no way of actually doing this until Microsoft invented it, and they called it restricted iframes. It's pretty much the predecessor or the precursor to the development of sandbox iframes, but it was there years and years and years before that. And basically, you had the possibility to load an external resource in an iframe and say, look, you're not trusted. You can't do anything. You can't do audio. You can't do video. You can't do scripting. You can't annoy people. This just doesn't fly. It's untrusted script. That should be good, and it gives us another tool, right? Now we have content transformation. We escape, and we encode. And we have content restriction. We define who and what can do what and where by simply saying, look, we can trust you or we can't trust you. That's pretty much it. It's not as simple anymore, because once trust is being added to like a security model, usually it's already, something is already quite wrong, because trust is hard to define and an extremely complex topic, but at least there's another tool that we can use. So are we close to fixing it yet? Probably. Let's see. Well, then there was another thing happening, and what reads here is German that says like git Würmer, that says like yuck, there's worms. And people figured quite quickly out what they could do with cross-site scripting attacks if they went from the classic alert to doing something actually creative. And they looked at certain platforms like social media platforms, like MySpace, or web mailers or stuff like this, and they realized, wait a second, if I can execute JavaScript on behalf of the logged in victim, then I can do whatever the victim can do. So that means I can just like emit clicks and keystrokes and do all sorts of things. So that means in a web mailer, I can likely send emails. Normally only the victim can do this, or the legitimate user, but the cross-site scripting can do this as well. And depending on the context of the site, you can do a lot of stuff. Usually the sky is the limit. And people figured that out, and people did that and played with this. In the year 3AX, there was the mention of the Advogado virus. And the Advogado virus was something that basically had the possibility of injecting JavaScript and HTML into an existing website and then propagate from there and infect other websites as well. So the user would go there, and then it would kind of propagate to the contacts, and at some point you have a lot of infected users with a lot of impact and a lot of calculation and computing power, and it gets interesting. Then needless to say, there was MySpace, that thing that Sammy actually unleashed a couple of years ago. And he also basically found a way to take his payload, and when people visited his profile, he would take his payload, put it into their profile as well, and when other people visited their profile, well, you kind of can see what happens. It spread exponentially, and it was pretty bad. And also, he went to prison for that, so that wasn't good. Don't do this at home. And in the year 6 after cross-site scripting, there was a paper by Wade Elkhorn, who was long time behind Beef, and he pretty much specified what needs to be done to create a cross-site scripting virus. He created a proof of concept, he specified what is necessary in terms of components, and you can see in those early years, in 2005, people were already all around that. Like, they realized what's going on, what you can do, what the potential is, and some of them even did it. But the problem is, to tackle this particular kind of thing, you can't just have encoding, you need more. Because in these situations, you usually have websites or platforms that want the user to submit rich text. And this rich text to be stored and then to be shown. Could be like a web mailer. Of course, you have rich text in your emails that you send. Could be like your Facebook profile or anything else that requires you to have like bold fonts and red backgrounds and all these things. So now this is a new challenge. Because by using encoding, we destroy all that, and we don't want this. So what we have to do is we have to find a way to sanitize, to tell apart the good from the bad parts, and only leave the good parts and throw out the bad parts, and then hopefully be safe. That was being done, and all of a sudden everybody wrote their own sanitizer. As you can imagine that most of them are extremely bad, and you should never use them, don't touch them with a stick. But there's many of them. There's HTML Purifier, which is actually quite good. There's Anti-Semi, which has been discontinued. It's now an OWASP project. There's HTML Lot, which you should never use. It's really, really broken. There's Wash HTML. I'm not really sure how to actually pronounce it. It's used in Roundcube. Don't use it. Oh, by the way, also don't use Roundcube. There is CSS that was used for WordPress a while ago, then they forked it and they kind of do something else now. There's Safe HTML, and then there's Sanitize HTML, HTML Sanitizer, HTML-Sanitizer, HTML Space Sanitizer, and HTML Rule Sanitizer, and last but not least, there's Google Kaha, which also has been discontinued. I have no idea if any of these are good. I know that HTML Purifier is pretty good, and I know that the next project that came out of this one here is pretty good, but that's pretty much all I know. I created a sanitizer myself, because why not? I called it DOM Purify. It's still maintained and still very active. About 180,000 people download it per month. And it's a good tool. However, it doesn't run on the server. It runs in the browser directly, so it has different use cases and different attack scenarios. But the fun thing is that pretty much most of these sanitizers had a bug or a problem at some point, so we can't really trust them. Here's like a quote that I really liked, and I found it on the SourceForge page of CSS. And it says, CSS is an XHTML filter written in PHP. It's a good sign in the first place. It removes all unwanted HTML elements and attributes, and it also does several checks on attribute values. CSS can be used to avoid cross-site scripting XSS. Note, I don't have time for CSS right now. That's awesome. So there's this guy, and he writes a security tool, and then he tells people on the SourceForge page, yeah, I don't really have time for this right now, so your mileage may vary. Like, whatever happens, I don't really care. So this product description is like so vague. It's like, yeah, some things we remove. Maybe it does this, maybe it does that, but also I don't really have time for this, so yeah. Most of the other tools going in this direction had a similar level of seriousness. So you can kind of imagine all of them had bypasses. Like literally all of them, including our own. Of course we had bypasses too. Some of the bypasses were reported and then were fixed. Some of them were not reported, so they're still there. Some were attempted to be fixed by the developers, and then they failed, and it had to be done again. And some simply ignored the reports. So sometimes you don't get feedback from the maintainers. It's like, yeah, that's not really our problem. Or, hey, I'm doing something else right now. Or, hey, I retired. I'm in southern France right now in my small house. Who knows? So maybe we have to change the title slide. Because maybe the title slide is not that super accurate anymore. I mean, XSS sort of is that because we have all those tools, we have all those sanitizers and encoding and escaping and trust and all these things, but we somehow don't seem to have the possibility to use them the right way. We seem to be not smart enough because whatever tool we create, it's either insufficient or broken or we use it the wrong way, and that's maybe why we still have cross-site scripting. Maybe. Maybe not. Maybe the reason is a different one. I'm just trying to get closer here. So the tools we have. are content transformation. We mentioned them before. We escape, we encode, we don't echo before we actually do this. We have content sanitization. We tell apart the bad from the good. We leave only the good and work with that. And we have, last but not least, content restriction. So we add trust. We define who and what can do what and where. Sorry. And to be quite honest, those three tools really fix 99.9% of all the cross-site scripting problems. We just have to use them the right way. That is all that we need to do. Somehow we seem to be stuck in using them the wrong way, or propagating wrong use, or having broken tools in the first place, but this can be fixed. So I wanted to have a look at what academia says about this, because when a problem slowly blows up out of proportion, then usually academia is there and tries to harvest some papers. I did so myself, so no blame. Most of cross-site scripting is covered, and I wanted to find out what happened in the year 8 after cross-site scripting, in the year 2007, what academia did until then. And with Google Scholar, you can do like these date windows, and you can find out how many people were actually publishing about a certain thing in a certain time frame. And I checked for cross-site scripting, and I gave it a custom date range, and it told me that there is like 1,930 different papers and articles about cross-site scripting. Holy shit, that's like too much. Like, this is impossible, 1,930, and no actual process, no actual progress. Sorry. So, even though academia really went the whole 9 yards here and tried to kind of fix it, they didn't seem to manage because cross-site scripting is still around. 2,000 papers didn't fix it. Well, maybe the reason is that there's like a lot of niche problems and edge cases and special situations where even if you use those three tools that we have consistently and the right way, then you still have cross-site scripting on the possibility for people to inject stuff into your website. Because there's like DOM XSS with like location search, location hash, and all these properties. Then there's mutation XSS, where style properties are changing when being treated by the browser and stuff like this. And this is maybe something where those tools can't really help because they're not strong enough or not fine-grained enough. What can we do if those tools are not enough? One of my favorite ones is MIME Sniffing XSS scripting. Basically, in most situations where you want to inject HTML and JavaScript, you need to have some kind of scaffold around where you inject into, so it actually executes as HTML or SVG or XML. But if you, for example, inject into something that would be returned from the server as plain text or as application JSON, then you usually say, well, JSON and plain text, they don't really execute anything if you open them directly, so we don't have to encode here. It's not true because a couple of browsers, including latest versions of Microsoft Internet Explorer, still execute JavaScript and HTML from text files, if you iframe them from an EML file. And it's again IE 11 that executes JavaScript from JSON files, if you iframe them with a regular page and then reload the iframe once and it forgets the content type, and boom, you have code execution. It's documented in our browser security papers, you can read it up in there. And there's more and more and more of these weird niche cases still in the year 20 after cross-site scripting. And they can't easily be tackled with our tools, with our encoding tools, or with our trust or sanitization tools. I mean, they could, but we have to know that it's an issue to actually apply those tools there. Then there was plugin XSS. I really like this one. It's quite a while ago. It was, I think, in 2009, when Adobe's PDF reader had a bug, and you can pretty much open any PDF, like whatever PDF out there, and you would use any parameter name, whatever you could come up with, and you would call it JavaScript alert 1, and then it would execute, just so. Because they were like, oh, this is like a JavaScript URI, we should kind of parse this and put this into an eval. No one knows why, but they did this back then, and this pretty much meant that every single website out there had cross-site scripting if the victim had Adobe Reader installed. And of course, pretty much everybody had this installed, so that was kind of bad. And this is one of the situations where those three tools that we have really don't help. Like, there's nothing they could do because it's a problem in a different software that plugs itself into the browser, and the software needs to fix it and people need to upgrade. Whatever you do as a developer, you can't do anything. I remember that back then people were seriously recommending to developers to delete all the PDFs from the web root. Come on, man, just like wait for the fix, it's not that bad. Anyway, so we can see the tools that we had so far, binary trust, encoding, escaping, and sanitization, are not really 100% enough. There's still like a couple of niche cases that we need to address, that we need to tackle. And we need something that's more granular. Needless to say that it's also more complex, but let's see what is there. Probably everybody here knows CSP, right? As far as I know, in track 2, there's like a CSP talk happening right now. But CSP, Content Security Policy, allows us to do that exact thing. We can kind of define a rule set that clarifies whom to trust and from whom to execute JavaScript, fetch images, and whatnot. CSP had its origin in the year 5 after cross-site scripting. That's the year 2004. Few people know that. And it was called, not CSP, but Content Restriction 0.5. And it was created by Gervais Markham of Mozilla back then. And he basically says, yeah, we need headers, and these headers need to specify trust and do things. And well, then we should be able to kind of make sure that the evil guys can't execute JavaScript on our website anymore because we don't trust them in the first place. We only trust us, and then we're done. Yeah, the result from that, this back then very simple approach, was a more complex thing, co-developed by Brandon Stern from Mozilla. And they called it Content Security Policy, CSP. And meanwhile, we're at CSP version 3.0, and it gets bigger and bigger, and there's more directives and more complexity and more implementation work for browsers, and still cross-site scripting is around. And I believe that the problem with CSP is that it's too complex and not really suited for the use case. It's pretty much like this gun that tries to shoot in all 4 directions at the same time, but never hits the target. And I think CSP is great for websites that have one single purpose. For example, something like global leaks or secure drop, like something where you can't have any attacks against, something that needs to be secure and only does one thing, but this thing really, really well. But if you look at a website like Facebook or something that has like decent complexity, how are you going to put CSP in there? How are you going to tell apart the bad from the good, the trusted from the untrusted? There's literally no way. And it's quite interesting because we have a couple of clients that come at us and then basically say like, hey, so we created CSP policies for our website and we want to have a review. Can you have a look at our CSP? So they don't come for us for pen tests, they exclusively come at us for CSP reviews and want us to tell them whether their CSP policy is actually good, if the 2 years that they invested were well invested, or if it turns out that the rules are broken and we can still bypass them. And we looked at the one from Facebook, and I encouraged you to have a look at the CSP policy from Facebook as well, because it's ridiculous. It doesn't do anything. It's like pretty much half a kilobyte of absolute nothing. It has no purpose because in the first line it essentially says default source is asterisk. So they pretty much trust everything. Then why have CSP in the first place if you trust everything? Look it up. It should be online right now. We refer to this as cargo cult CSP. Do you know what cargo cult is? Who knows what cargo cult is? I think it's like the perfect example here, or like the perfect metaphor. It's actually quite a sad story. Imagine you're like an indigenous people, you're living in the Amazon jungle, right? And then you're living there and you're hunting and you're doing your stuff and you're like in unity with the forest and everything is like perfectly fine. And then someone comes with like a silver bird, aka airplane, look at these, and lands on a landing strip that they made, and then there's like weird people coming out with different skin color and they do stuff in your jungle and you're like, wow, who are those people? They come with silver birds, holy shit, they must be gods. And at some point they disappear again because they did whatever they wanted to do, and you're like, oh man, it would be really good if the gods came back because that was so cool. So they need this landing strip, right? So here's what we're gonna do. We're gonna chop some trees and we're gonna create some planks, and then we build like an artificial landing strip for them because maybe then they come back. Needless to say, building a wooden artificial landing strip is not gonna make the gods and their silver birds come back. So this is kind of futile, but people at least believe that they might come back and that they're trying the hardest they can, and maybe it works. And I have the feeling that with many CSP policies that we see, it's the very same thing. People just hope that maybe magically with the bullshit that they put into their headers, they're actually gonna fix cross-site scripting, but they don't because those policies are meaningless and just a waste of space. So it's expensive to implement, it's hard to get right, there's browser bugs, there's bypasses, and it's not yet the solution. And I'm not really sure if it will ever be the solution because there's a lot of unrest in the specification. I think like, okay, this is bad, and that is bad, and this we can't do, and this we can't do, so we kind of have to invent this, and then we have to invent that. And it's growing more and more complex. And I'm not really sure if investing more time into this thing actually helps. So we have another tool, but it's, again, not enough, or not suited for most of the use cases that actually exist out there. There's a lot of new security features coming at us, and some of them are already live in the Canary versions, or will be live, or are hidden behind a flag. And there's tons of stuff, like sandbox iframes we know already. We've had them for ages. We basically have the possibility to add more granularity to the trust of externally loaded content. Same with sub-resource integrity, which kind of checks for hashes when we request something external from a CDN or something like this. There's sub-oranges to kind of isolate different apps from each other that are residing in the same origin. There's permission delegation, trusted types, the referrer policy, and tons of other things. If you want to find out how much is happening right now in the realm of web security and browser security, go to the platform status pages, to the Chrome platform status page, or to Edge status page, or to Mozilla's pages, and check out how many new features are actually relating to security. They have like a little search field. You can just like go in there and check it out, and you will see, oh my God, this is like 38 new features coming in the next 3 months that are all security relevant. We should know these things. We're pen testers or security developers. But the point is not that we should know these things. The point is that there's so much coming at us, so much new added complexity. And still we haven't solved the problem. And I'm not really sure if more is really the answer here. So the tools that we have. Content transformation, we escape stuff, we encode stuff. It's for the easy things. Content sanitization, we tell the good stuff apart from the bad, we only leave the good. Content restriction, we define who and what can do what and where, and we hope that the trustee is actually trustable, because we don't know that. Maybe jQuery.com got hacked and they deployed bad JavaScript, no? Maybe ajax.googleapis.com has insecure JavaScript, who knows? We can just hope that everything's fine, and that our policies are holding and making sense in the end, and keep people from injecting JavaScript into our website. So again, I think I have to change the title slide because it's again not accurate anymore. Cross-site scripting is dead, we just forget about this. Because we have all the tools and the tools are good, but we don't use them. Content transformation, people just forget to escape and to encode, and this is how we find bugs and then we get money for them. Content sanitization, sanitizer gets bypassed, the authors don't fix it, so what? Or it's being used in such weird context that something completely different must happen to diffuse it. Or the sanitizer library that is being in use is outdated because the website owners don't update this thing. Or the website is abandoned but still has users, who knows? And content restriction, well, it's just too much work. Or ads won't work anymore. We have a couple of clients that we asked, look, why don't you use CSP? Not that we wanted to encourage them to use CSP, we just wanted to know why they don't use CSP in the first place. It's like, yeah, we checked it, but we have so many affiliates and partners, and we want to buy iframe, we want to be iframed by those, but not by these, and then we have like ads and tracking and all these garbage scripts, so if we don't have these, we lose a lot of money, and if we have CSP, we can't have those, or we have a policy that is so generous that it doesn't do anything in the first place, like Facebook's. So that's kind of complicated. No one really wants to fix it, or sometimes people forget about fixing it the right way, and we're not really moving forward. So I think we've seen enough of history and where we actually are right now to kind of formulate a problem statement. And to be able to solve something, we need to have a problem first. And maybe we don't even really know what the problem is with cross-site scripting because it's so complex, or it has grown so complex over time. So year 20AX, which is where we are right now, 2018. We have all the research. We know what cross-site scripting is. We know how it works. Everybody can do it. It's actually quite easy to learn. We have all the tools, the encoding, the escaping, the sanitization, the trust, and so on. We pretty much know all those nasty tricks because there's always tricks and browser bugs and these things. And I noticed that in the golden years, a couple of years ago, like 5 years ago, people were like publishing cross-site scripting tricks all over the place. But this has decreased, like it's not happening anymore. It's pretty much flatlining because there is not many tricks left. There's maybe something exotic here, maybe something exotic there, but this gold rush that we had a couple of years ago when everybody and their dog was finding new attack techniques every day, this is over and it's not gonna come back. We know all the risks. We know what worms are. We know what you can do with cross-site scripting. We have seen live attacks. We have seen server going down. We have seen code execution. We have seen all the mess that is happening on the crypto websites with their wallet implementations on a website because you put some JavaScript into the transaction commit and then you're rich. We know all that. We know that it's real. We know how to fight it. We know what it does, what it is, and we have pretty much found almost all the tricks that exist to sneak it in anyway. We know how to kill it, but we don't do it. And the question is why? Why is this still a topic? Why am I still standing here and talking about this topic? And is this maybe something that is symptomatic maybe for other security problems as well, or for other technologies as well? Let's see. I think there might be like a variety of reasons. The stuff that we usually hear when talking to developers after a penetration test is like, yeah, we just forgot to escape this one time. Normally we do it, but this one time we forgot it. All right. Or yeah, this is like the legacy system. In the legacy system, we don't do patches anymore. It's just like we migrate slowly to the new one. This is much safer. Or we don't have budget for security right now because management decided that security is something that should be tackled at a later point in time. Or people say, yeah, that's not really an issue for us because we don't really see that scenario. Our custom code is much faster than any framework. We don't have to have auto-escaping, so yeah, that happens. Or our advertisers don't like CSP, it's too restrictive. Or the developer who wrote this code is now selling used cars and can't take care of this anymore, and we don't have any idea about the code. We actually heard a story like this, and it was a bit more tragic because someone died, and that was horrifying, because they lost the developer to an accident, and then pretty much the entire code base was useless to them, and they couldn't fix the bugs anymore because they didn't know how. So that's a couple of reasons. But we're turning ourselves, what I believe, into chief excuse officers because we basically come up with more and more excuses that effectively try to hide that we don't really want to fix it, and that we don't really have time for that, and that we're actually quite comfortable with the situation as it is. We cannot implement foo because bar, or I was dehydrated when writing that code. Or we delegate guilt and responsibility. And that's something that pretty much everybody in here likely does, including myself. Yeah, that was the dirty intern, like they wrote this code, like blame them. Or the project lead accepted the risk. Or management is not granting us security budget. There's always some sort of excuse that we can come up with and say like, yeah, but this bug, like this is totally not our fault. And what we could derive from that is the assumption that the fish rots from the head down. Basically, this is like a flying word that basically says management, it's management's fault. They don't give us money. It's them up there, like it's all their fault. Which is, of course, extreme nonsense. Because I think it's all of us. I think it's like the entire community, developers, security people, pen testers, even myself. We all suck. We don't really want to fix the problem because we're actually quite comfortable with the situation as it is. And I ran into like a very interesting situation a while ago. That was about half a year ago. And it was in India at Nalcon in Goa. And it was quite late already. I was pretty hammered. And I was going to the bar to grab another beer. And I was talking to a friend over there. And I was like, yeah, I'm doing like this talk about how cross-site scripting is dead, but not really. It's like, oh, interesting, interesting. And then he looked at me and says like, oh man, I hope cross-site scripting is never gonna die because then a lot of people are gonna lose a lot of money. It's like, wow, that's kind of exactly the material that I need for my presentation because yeah, if that actually happens, if this particular entire attack class dies, then a lot of people will lose money. A lot of business models will not exist anymore or shrink. So why would we want to fix cross-site scripting if all that happens as a consequence is us losing money or losing incentives? We would suffer financially. Who here would suffer financially if cross-site scripting was solved all of a sudden, if it was gone? Just me? 2 people, okay, thank you. So that kind of sucks, and it makes it hard to fix a problem if we don't want to, if we don't have any motivation, if we don't have any incentives. So now the question is like, what do we really want? Do we really want to solve cross-site scripting? Or do we just like pretend to our clients, to our customers, to our users that we do so and tell them, oh yeah, you need to do this, you need to do that. But secretly, we hope that the issue is going to be around for a long, long time because it's sweet, sweet money. And it is. I have to ask that myself. Do I want to keep popping alerts until I'm 85 and make money with them? Or do I kind of at some point want to move to something else? Not sure yet. So what do you think? Should we like solve cross-site scripting and be done with it? Because I think we can do it. Or should we just leave things as they are? Who is for solving cross-site scripting and kind of getting rid of it? A couple of people are for solving it. Who wants to keep things as they are? Not that many. It's fine. Not judging, not judging. Anyway, so a couple of people want to solve it. A couple of people want to leave it as it is. Let's move to the final act and ask ourselves, do what now? Can we do anything about this? Is there anything that we can kind of derive from this rant? Anything that's productive or constructive at least? I don't know. If we want to solve it, we need to ask ourselves the question, do we really need more tools? Do we really need more stuff in the browser, on the server, in our headers to actually feed to developers and ask them to implement? Do we need more HTTP-only cookies? Do we need more CSP or whatever other proposal? Do we need sec metadata or yet another layer in the stack? Do we need more complexity? And are we all working in the right direction as pen testers, as browser vendors, as developers, and certainly also as users? I found this thing on the shipping announcements for Chrome, and it's about sec headers or sec metadata, one of the new headers that is implemented pretty much right now. And it says, as this mechanism is simply an additional HTTP header, there's little risk created by shipping it. Other vendors can pick it up over time, or if it turns out to be a bad idea, we can drop it without much fanfare. Which is awesome because it basically says like, yeah, so let's think about like a feature for security and we have really no idea if it's any good. Let's just try it out, and if it's shit, then we remove it again. So let's see. This kind of shows me that there's like not really much focus anymore and that people actually don't really know what to do anymore, so they just try. It's like a shotgun approach. It's like maybe we can fix it with this, maybe not. If not, then we just delete it again, which is quite funny. Quick glance at academia in the meantime. So, I mean, papers solve everything. And I checked from the beginning of days to today how many papers have meanwhile been written. Remember before it was 1,930, and then I checked from back then to now, and it was like 19,500 papers. Holy shit, like this is ridiculous. And still the problem is around, so papers don't fix it. And you can write as many as you want and get your currency in academia to get your PhD. It doesn't have any actual contribution, sorry. But well, pencils down. We need to maybe kind of step back a little bit and think about what actually is missing for us, for all of us, to solve this particular problem. And I think what is missing is motivation. We don't have the right motivation because we do all these things for completely different purposes, and that's wrong because that ruins it. How about we think about adding some motivation through punishment? I like punishment. So we use punishment pretty much everywhere. We use punishment to fight crime and keep people from speeding, and we raise our kids using punishment, hopefully not that much. Why do we not punish developers for the security bugs that they create? Could have like a small box with kitty litter, and every time the developer creates like a bug, it's like into the head with the kitty litter it goes. Super disgusting. The developer would not produce any security bugs anytime soon. So maybe that works. You think that works? Punishment is a good thing? Excellent, I like it. We should have a beer. Or we use gratification. Maybe that's better. We use gratification for like bonus systems, or compromise managers, or giving out trophies, badges, awards, candy for good grades. Maybe we can put some candy into the kitty litter that the developer can grab. Well, no, we shouldn't do this. But well, why not reward developers for producing fewer security bugs, for actually contributing to more secure software? Like, why don't we do this? Maybe this works. Who thinks this is going to work, like gratification, giving people candy? Again, everything works. Excellent. Maybe we should also kind of try to find out who introduced the security bug. I mean, it's not always as obvious as it was with Badlock, like this particular disaster, but we need to find out who actually did the XSS, who put it in the code, who added the SQL injection, who added the code injection, who did it, and who reviewed the code and then greenlit it, and why. Someone must have done it. And we need to talk to those people and kind of explain to them that this was like a bad idea and tell them how to do it better in the future so that same issue doesn't pop up again. How about like a fix of a month? How about gratifying developers for outstanding performance in securing the platform even more? Fix challenges, fix bounties or something like this. But then it kind of gets us again into the situation of saying like we put ourselves on a very high horse, and it's again us suggesting to others what to do. And the point that I'm trying to make is that it's all of us that are involved in this. We need to maybe start with ourselves. And I think one of the ways to actually get there and getting the right motivation to actually fix entire attack classes would be to stop the bug fetish, because I think we have a serious bug fetish. We love bugs so much. It's like, whoa, look at this critical, look at this, logo bug here, logo bug there, everything is fucked. Like, this is bad. This is not a healthy attitude. This is not an attitude that actually allows us to fix things and to keep them fixed. We keep fetishizing the bug, but not the fix. We praise the bug hunters, but not the fixers. We completely ignore those people who do the dirty work afterwards. Our entire mindset is around bugs and not the fixes. It's not secure software that we want, it's bugs, bugs, bugs. Including myself, I'm not judging. Maybe we could have fixed bounties. NCC and Google do it already, sort of. And I wanted to find out how many people actually do fix bounties. And if you look for fixed bounties or patch bounties on Google, you will find 2,000 hits. So that's not that many. And then you look for bug bounties and you find 431,000 hits. So that kind of tells us something, like this weird ratio. So we keep glorifying the finder, but not the fixer. We have like interviews with legendary bug hunters. We have like media campaigns to raise awareness, self-proclaimed super hackers and people who kind of call themselves cross-site scripting gods and masters and this and this and that. It's all bullshit. It makes no sense. And they get praise. For what? We have top lists, halls of fame, award ceremonies. What's next? An audience with the Pope? I don't know. I would kind of propose for us to stop doing this, to stop living this bug fetish, or at least give the fixers some glory as well, because they deserve it. Not everybody agrees with this. I received a response 2 days ago or 3 days ago about this. Like, he was very much in disagreement with this particular bit of the presentation. It's just like, no, there's no way we can do this. We need to punish developers, and like they produce the buggy software. Fair enough. Not everybody has to agree. But what we can agree on, and this is pretty much the end of this particular presentation, we don't really have a working solution yet. And the problem is not that we don't have enough technology. I don't have the solution, needless to say. I'm probably part of the problem as well, but maybe if we start realizing what and who and where the problem is actually located, we can kind of find out how to get there and solve it, because this is what we need to do. And I think it's all of us that can contribute to this, not just a couple of people, not just academia, not just industry, not just researchers. And I think we need to start by being honest. We need to either say, all right, I don't want to fix it. I'm fine with the status quo. I'm not complaining or judging, as mentioned. But at some point, it's going to fix anyway, and you need to rethink your business model. Or you can say, well, I do want to fix it, and then I want to explore what is afterwards, what's happening after that. Then interesting. Let's meet, let's discuss, let's talk about this. Let's together use Occam's razor, strip off all the nonsense, strip off all the bullshit, and identify the actual obstacle, and then work on this and create a new post-cross-site scripting security business models, because they exist. There's still so much more stuff to explore, and it's getting interesting. So I think we can now conclude and say cross-site scripting is indeed dead. We have everything that we need. We just need to accept it for ourselves. We need to have the motivation to actually pull it off, to accept that it's dead, that we have all that is there, that we don't need additional technology, and that pretty much we're good to go. And now the only thing is, if you want it, let's do it. Let's throw away all the other garbage and let's focus on solving the problem, identifying the problem the right way in the first place. And if not, then not. But then please don't stand in the way of those who will, because that's actually quite annoying. And that's pretty much it. So, summary, I think we have all that we need. We have all the tools, we have all the knowledge, we have all the research, we know all the tricks. What we're lacking is the motivation, and we need to kind of get together and build up this motivation, and then we can actually do this, and we can kill this and maybe other attack classes if we so want. Thank you very much.